Welcome to the webinar for April 2019. My name is Tom Carpenter. I'm the CTO at CWNP. And this month, the topic of our webinar is the 5G versus Wi-Fi battle. This is not intended to be a technical deep dive into 5G technologies, though we will talk about some of the technical capabilities and specifications related to it, such as frequencies that it uses and the impact that has on capabilities and so forth. But mainly it's to address this issue that has come up over the last couple of years of, will 5G be the Wi-Fi killer? Will Wi-Fi continue to survive in a 5G world? And I think the past will answer that question in part, but we're going to look at why this issue even came up in the first place and the reality that, well, let's just say Wi-Fi is here for at least quite a while. So let's dive right in and see what we're going to be looking at here today. Now, first of all, the agenda, we're going to talk about what is 5G. So we'll get kind of an overview of 5G, the 5G new radio frequency bands. 5G NR is really just the specification for what 5G is finally becoming. Let's just put it that way to oversimplify it. And I'm going to talk about supplanter challenges, because if 5G was to kill Wi-Fi, it would have to overcome supplanter challenges that are always there with technologies. So then I'll give you my opinion as to what we will see and what we won't see, kind of the positive and negative aspects of it, and what you should learn, what you should begin to develop as far as skill sets based on 5G as well as Wi-Fi in the future. So first of all, there's been a history to cellular communications, obviously. So in, roughly circa 1980s, we had 1G, 2G, the 90s, 3G, the 2000s, 4G, the 2010s, and 5G, the 2020s. So are you seeing a pattern here? About every 10 years, we see a new G, right? G standing for generation. So we could probably expect a 6G, right? To be around the 2030s and so forth. So is 5G the future? No, it's no more the future than 4G was, or 3G, or 2G, or 1G. It's maybe the decade is what we can get by with saying. Now, granted, we're not even in the 2020s yet, and we've already seen some 5G deployments. There are people right now that are using 5G in a privatized manner in some deployment types. We saw 5G deployed at the Olympics, remember, a couple of years ago. So certainly 5G has been around, but it's important to know that there's 5G, then there's 5G, then there's 5G, then there's 5G. What I mean by that is 5G is less something we're going to get all at a moment and something more that is and will be evolving over time. So you could say that we got 4G, but then we kind of got 4G 4.1 and 4.2 and 4.5 and leading up to eventually we'll have 5G, and guess what? There'll be a 5G.1 and a 5G.2 as the features and capabilities are added. It's very similar for those of us that are familiar with the Wi-Fi space with what happens with new Wi-Fi. Remember when 802.11n and AC came along? The first versions were kind of minimalist capabilities of the new standard. And then more capabilities were added over time to later devices that were based on 11N or 11AC. And we'll see that with 11AX as well, right? Well, it's the same thing with 5G. There's a release 15 standard. There's a release 16 standard expected later this year. So the point is that there are capabilities in those releases that vary, that are different. And so we can't expect that when the standard's not even available yet, that we already have those new capabilities. So the current 5G stuff people are deploying now is not the 5G stuff that will be deployed in 5 years. So it will evolve and it will grow, and we will grow that technology until eventually it is supplanted by 6G and then 7G or whatever we decide to call it in the future. So what is 5G? Well, it's short for fifth generation. And the simple thing is that 5G is both a marketing term and it's a standard. So there are standard specifications that are created by 3GPP, and they develop these specifications for this new technology. They don't really worry about calling it 5G in the standards any more than people worry about calling 802.11ax Wi-Fi 6 in the standards. So it is about the technology and the capabilities that are being utilized. Basically, if a device or system uses a 5G NR or new radio, it's considered to be a 5G device or system. It's the successor to 4G. You probably guessed that and figured that out already. Now, actual implementations that have been done so far have seen speeds between 80 and 634 megabits per second down and 10 to 60 megabits per second up. Now, the reason I point that out is the goal of 5G, as we'll see momentarily, is 100 megabits per second everywhere, ubiquitous down, and up to 10 gigabit per second. So this is kind of the goal, right? And in the implementations we're seeing so far, we haven't quite seen that everywhere value of 100 megabits per second. We'll be seeing it, but we aren't seeing it now. Now, keep in mind, though, that could be based on early chipsets. It could be based on the signal quality of the devices that are connecting. It could be based on all kinds of factors that drive it down. So it might even be better to say the potential for 100 megabits per second everywhere. Now, the actual operation frequencies, and we'll get into this in a little bit more detail, will be less than 6 gigahertz, which is as low as 400 megahertz. That's the range starts there, though not necessarily planned to be used at 400 megahertz, and 24 gigahertz or greater. So Verizon, for example, uses 28 gigahertz. AT&T uses 39 gigahertz in the US. But that greater than 24 gigahertz is as high as 90 gigahertz. So that's very important to keep in mind. It could be up to as high as 90 gigahertz, and we're seeing some testing and analysis in the 70 and 80 gigahertz ranges. Not that we'll see anything implemented in the near future with that. It's just being tested. Technically, millimeter wave, or MMW, is defined between 30 and 300 gigahertz traditionally. But now we tend to refer to anything that's 24 gigahertz or up, since that's what we're using, as millimeter wave as well. So you'll see that term millimeter wave. And when you go look at technical specs for what is a millimeter wave in physics documents and things like that, you'll see 30 to 300 gigahertz. But that's just old school thinking. And based on the length of the wave, is it less than a centimeter, and therefore measured in millimeters, it makes sense to call it a millimeter wave. So it's based on the wavelength. It is called extremely high frequency when referring to that 30 to 300 gigahertz range. Now, millimeter wave is mostly line of sight. This is very important to keep in mind because the millimeter waves do not reflect as well as the microwaves do. And because of this, they do not propagate throughout a space as well. So they're very good for direct line of sight, or fixed wireless, it's sometimes called, links. Because we can get high data rates, we've got high bandwidth, but we do need line of sight for many of those. There's still some testing on its potential use in non-line of sight scenarios, so we'll see how that pans out in the future. Interestingly, if you avoid specifically 24 gigahertz and specifically 60 gigahertz, and there are some other frequencies as well, then it can provide greater range. And this is because the oxygen or water vapor, depending, absorbs less of the energy outside of those ranges. So it's in 24 and 60 gigahertz where specifically oxygen and water vapor absorbs the RF more than some of those other millimeter wave frequencies. And so you will see there's some 24.2, 24.5, but many people are looking at 29 gigahertz, 39 gigahertz, and others, 28 gigahertz, as good targets because of this issue, at least in part because of this issue. It has to do with, obviously, available frequency and things like that as well. So here are the frequency bands. We divide them into two ranges, frequency range 1 and frequency range 2, FR1 and FR2. And FR1 is from 400 megahertz to 6 gigahertz, and FR2 is from 24 gigahertz to 53 gigahertz. Now, most of the people with me today are very familiar with these lower ranges because we've been using them in Wi-Fi for years, right? And we've used them with wireless phones, 900 megahertz phones, things like that. If you do ham radio, you've used some of these lower frequencies. So we're used to these lower frequencies from 400 to 6,000 megahertz. The higher ones, we really haven't used as much. Now, they've been available. They've been available for 802.11ad, for example, to use the 60 gigahertz frequency band, but we haven't really done much with it, have we? The big thing I want to drive home is, as a difference between these, is the cell size, the range capacity. So the range for FR1 is larger than that for FR2. And this is because of the ability to build antennas and so forth that can receive the signals at greater distances and so on. But FR2 can give us higher capacity because we can use wider channels and we can push more data through. And FR1 gives us lower capacity, and we generally have smaller chunks of frequency available to us in that lower space as well. So there are trade-offs either way. But the big thing I want to drive home here is the difference in cell size that's available to you based on whether you're in FR1 or FR2. Now, we're not going to get into the specific details necessarily of which frequencies specifically are used in which country. There was a reference to that here where you saw Verizon using 28 gigahertz, AT&T using 39. We're not going to go into great details on that kind of thing, however, here in the presentation today. Now, what were the generic goals? Well, it depends on who you ask, but in general, the goals of 5G were 10 to 100 times more devices connected. So they want more devices connected at the same time. 10 gigabits per second rates peak, 100 megabits per second universal, less than 1 millisecond latency. And by the way, that has not been achieved in a few of the 5G deployments that have been implemented. Latency has been a little bit higher, to say the least, but it is a goal of 5G in general. Engineering of these solutions will, of course, improve over time. 10 years battery life on low power solutions, so the ability to use low power devices and use them for long periods of time without changing batteries, and 10,000 times more traffic compared with the launch time of 4G. So 4G, we saw earlier, about 2010, right? So whatever traffic was going on in 2010, we want to be able to handle 10,000 times more traffic than that. So these are just some general goals that have been stipulated for 5G. Now, here's the big thing. 5G will grow. So phase now, I'll call it, 2018 to 2020, what's going on with 5G right now, for the most part, is we're just using it for phones and exactly in the ways we use 4G, but faster. So we're not really coming up with new technologies because we have it. And even for the phase later I'm going to talk about, we're already doing this stuff. It's just that we'll be able to do it better with 5G because we'll have greater data rates. So the new solutions, phase later, which we'll probably start to see heavily used in 2020 through 2025, is smart city, industry 4.0, smart agro, gaming, health monitoring. So smart city obviously means connected cities and being able to do monitoring of the city. So it could be anything from traffic to water to utilities to city workers. All of this is part of this whole big thing called smart city. It's basically city management with intelligence, compute intelligence. Industry 4.0. This is the big artificial machine learning, deep learning movement of the future. And of course, the big thing is that information is distributed. Information does not come from one place. And because information does not come from one place, we have to be concerned about the fact of distributed information, which means that information needs to be brought back together for analysis, right? Well, the concept then is that this machine learning and artificial intelligence that we can utilize depends on getting the data. That means the data has to traverse networks. Now, the good news is it's usually very small pieces of data that traverse the network at very lengthy intervals. And so it's not that it needs a massive amount of bandwidth, but we need connectivity in order for it to happen. And the question is, do we go with Wi-Fi for our Industry 4.0 project, or do we go with 5G or something else? And by something else, I mean something like Zigbee, or Bluetooth even, or any other number of technologies, even proprietary technologies that are used. Smart agro is about monitoring in agriculture. This can range from research projects in the rainforest to monitoring crop growth in coffee bean fields. So whatever it happens to be, this is that general category of smart agro. Gaming, well, the big thing is we've already seen with 4G the evolution of gaming that has happened, right? We've seen more complex phone-based games or mobile games because of the network bandwidth available. So you can imagine the increased capabilities there with VR and AR and other such things taking advantage of the 5G network. And then there's health monitoring. Health monitoring basically today relies on either the cellular network we have, 4G LTE, or Wi-Fi for devices to connect and communicate back with health providers. We may see this just continue to be used in that way, but the thing is that with 5G, we have greater speeds of connectivity, more data can be transmitted, more information could be communicated, even video streams if need be, and so forth. So these are some of the things we're going to start to see used more and more over the next 5 years. Now, here's the big thing. We've talked a little bit about 5G, what it is, where it's going to grow, what it's going to do. The Supplanter Challenges. So Supplanter Challenges are anytime a new technology comes along and it is assumed to be able to supplant an existing technology, it has to overcome some things. Let me give you a different technology as an example, IPv6 versus IPv4. So IPv6, we'll call that the supplanter, IPv4, the implemented or entrenched solution. Back in the 90s, people began talking about the fact I said, that IPv6 was going to take over and IPv4 wouldn't be used anymore. In the 90s, we were hearing that that was going to happen by around 2005 to 2010. Then around 2001 or 2, predictions started to change, and we said it'll probably be another decade, maybe between 2010 and 2005. Now here we are, 2019, 20 plus years after people were saying IPv6 was going to kill IPv4. And IPv4 is still by far the dominant local access IP protocol. And by local access, I mean your computer talking to the router talking to another router, the router talking to the server, whatever, in your company. IPv6 is being used. There's no question. It is being used. But IPv4 is still the dominant one. What was the challenge? Well, if the dominant one works well enough and people aren't too upset with how it performs, the motivation to move is simply not there to justify the expenditure of cost. So here's the thing. We already have massive Wi-Fi infrastructure deployments, right? We have Wi-Fi in pretty much every company in the world today, the vast majority of them. And since they already have Wi-Fi, the question to ask is, can I use it for what I'm trying to do, or do I need to deploy something else to accomplish it? So in other words, if I'm looking to implement some Industry 4.0 stuff, maybe some smart monitoring within my manufacturing environment, and I'm going to deploy this, the question is, are there sensors out there that work with Wi-Fi? Is my Wi-Fi acceptable for what those sensors are going to communicate and their connectivity? Will it accomplish the goals? If the answer is yes, I probably stay with Wi-Fi and I don't move to private 5G or private LTE. Additionally, I may have proprietary sensor technologies that are already deployed in a manufacturing environment and they're working fine. They're doing everything that I need. I need nothing more than what they give me until someone shows me the something more that would be advantageous or valuable to my organization. I have no motivation to move away from the proprietary technology that I have, as long as it's still supported when something breaks and I can still continue to use it. So you've got both Wi-Fi and non-Wi-Fi stuff that's already out there doing some of the things that 5G might do. And the reality then is you have to supplant that. You have to give a justifiable reason why we should fork over the money to actually go a different route, in this case with 5G. Another big issue is not just the infrastructure, but the clients that are out there. There's a massive pool of Wi-Fi clients, and they know how to talk to Wi-Fi, right? Your barcode scanners know how to talk to Wi-Fi. They don't know how to talk to 5G. So I would have to replace all of my barcode scanners. I would need laptops that have a 5G radio in them. And because there's a transition window, I need them to have Wi-Fi as well as 5G. I can't get by with just one. So sure, there might be a system on a chip or something that vendors can implement in their laptops that give us all the worlds that we might desire. But again, it's an issue of cost. Laptops will cost more. It's an issue of transition. Older solutions are generally cheaper. In other words, we have engineering processes, molds, machinery that builds chips. All of this exists. And because it all exists, we don't have a tremendous motivation to spend the extra money to go a different route if the older solutions are cheaper. And just to illustrate this, people build brand new IoT devices today with 2.4 gigahertz only chips in them that are 11N chips. And why do they do that? Simple. Because it's cheaper. It reduces their cost of goods, therefore gives them greater margin in sale. And so we see that done all based on cost per unit. So obviously, that is going to continue to be a key thing. The other one that is big is the knowledge pool is much larger. There aren't very many companies that could go to their networking staff today and say, hey, we want to do private LTE 5G. Which one of you knows how to do this so you can head this up for us? And they'll actually find someone. Very few organizations have those people. We're looking at having to go out to consultants to get it done. Now, the reality is that over time, that will change. Over time, 5G prices will come down. Over time, more 5G clients will be out there as mobile phones incorporate it, tablets, and even laptops. Over time, there will be more 5G deployment. So over time, these challenges will be addressed. But the key is over time and over how much time. So let's talk about that. Here's what I predict we will see over the next 5-year window. You're going to see public and private 5G. So as we look at the positive aspect first, in other words, taking it from a positive perspective of 5G, you're going to see public use similar to 4G LTE today over the next 5 years. People will have faster access with their phone, but they'll just have their phone. Because engineering gets better, because cell architecture and design is improved, we may see better stability and connectivity even again. So when we went from 1G to 2G, there was better consistency and stability. 2G to 3G, 3G to 4G saw the same thing. It was growing, it was improving. And now we'll see that again with 5G. So not just will we see greater performance improvements, we'll see greater stability eventually too because of 5G. That's just the law of increased engineering capabilities and skills, right? So the engineers get better and we get better results. Private's gaining momentum already. There are a large number of either 4G LTE private deployments going out today or 5G private. And by private, I simply mean we're not using a carrier network like Verizon or AT&T or somebody else. Instead, we're either licensing or using unlicensed space with these protocols and technologies to build our own private network. I know of 2 large-scale 5G private networks being deployed right now in the United States. And I know of several kind of in-building, you might say, 5G deployments that are taking place. We're going to see that continue to grow. And as it continues to grow, we will see more and more need for people with knowledge in those areas. Also, Wi-Fi will be performing better and better over the next 5 years. And so as well as 5G performing better, so will Wi-Fi. The difference is the barrier to entry to Wi-Fi, better performance is lower. What I mean by that is companies that currently have a staff of people that manage an 802.11n/AC wireless network already have the people that in short order can get up to speed to manage, implement, maintain an 11AX wireless network. The barrier to going to 5G is greater. Now, what I would say is a person that knows Wi-Fi well could probably get up to speed on 5G with a couple of weeks of training to the level where they could administer it and support it. But the time to get up to speed, if you already know 11AC well, is maybe a day or 2 of training at best, or you just research it on your own. Use some new books and resources, and you're ready to go with 11AX. So the point is, and I'm not minimizing 11AX changes, believe me, there are massive and significant changes there, But the difference from going from 11AC knowledge to 11AX knowledge to 11AC to 5G knowledge is massive. And there's a big, big difference there. More knowledge of the need for engineers. And what I mean by that is over the next 5 years, Wi-Fi will also get better because I think there's going to be an improved awareness. At least I'm going to do my part in building this awareness. One of the reasons why 4G LTE and eventually 5G is thought of as more stable and consistent than Wi-Fi is not because radios are somehow magically that much better or something like that. It's because the people that are implementing those are extremely well-trained, educated, and experienced. Whereas the Wi-Fi implementations that are built are often done by people that know networking but really don't know Wi-Fi well. We are, of course, at CWNP on a mission to change that, but we're going to continue to see that there's increased knowledge of the need for well-trained engineers to deploy Wi-Fi, just like 5G. And so if you implement Wi-Fi as a well-trained engineer, guess what? You actually get a stable, well-performing wireless network. That's the magic. Okay, so when we see that level of quality in engineering in Wi-Fi networks that is there in cellular networks, then guess what? We see similar results. So the technology itself is not at the extreme problem. The extreme problem is the lack of effective design and implementation of wireless networks. So kind of from the negative side, what we won't see 5G replacing Wi-Fi. Existing Wi-Fi will continue because the entire client population today is incompatible with 5G. So we don't really have 5G devices today, right? We have Wi-Fi devices. They can connect. So there's that issue that simply means that there will be a delay in any area where some organization may say, we're going to do away with Wi-Fi and just use 5G. There's a delay because you got to get the devices that support 5G. So that is a 2 to 4 year delay minimum, maybe more like 3 to 6. And 5G used only for public networks. So some people have been saying, no, it's just going to be just for public networks. We won't see any private implementations of 5G. I disagree with that. And there's two reasons. Number one, the potential for 5G in private networks is beneficial in a lot of areas, in a lot of ways. Number two, it's already being done. And so since it's already being done right now, we can't hardly say that it won't be done in the future. We're actually going to see a growth in private LTE and 5G. I predict significant growth over the next 5 years to the point where it's going to become something that on-staff people in companies need to know more about. Whereas today, it's mostly a consulting arrangement or a service provider arrangement. We're going to see that change. And just like you need in a very large company, someone on staff that knows Wi-Fi, you're going to need someone on staff that knows 5G. Now, therefore, what should you learn? I suggest you start learning everything you can about 5G new radio. There is actually a very good book. It's called 5G NR is the name of the book, The Next Generation Wireless Access Technology. So if you want to get started now, this would be an excellent book for you to get started on to begin your studies. It was released in 2018, so it is a newer book, and it's called, again, 5G NR, The Next Generation Wireless Access Technology. And it's actually published by Academic Press, an imprint of Elsevier. So that's a great place for you to start. And then if over time you want to go deeper, you can always feel free to email me, tom@cwnp.com, and ask me for recommendations for other materials, and I can help you with that. So that's a good place to start with 5G NR. Private LTE 5G, there aren't so many resources available for that specifically, but know that when you understand 5G NR, you kind of have what you need to understand private 5G and LTE. So that's really your good starting point, I would say, into grasping those issues. You also want to understand 5G and Wi-Fi coexistence. And this isn't so much they use the same frequencies, because we don't, in most cases, use the same frequencies today, but we'll see what devices come out in the future. and how the frequency space is allocated as time goes forward. But the key thing here is to know, how do I manage both of these at the same time? Now, the good news is, for all of this, CWSA begins the journey. The Certified Wireless Solutions Administrator is the beginning of a new track that CWNP is offering that we're kind of calling the rest of the wireless world. So the CWNA track, CWNA, CWSP, CWAP, CWDP, and eventually CWNE, is all focused on Wi-Fi, with little hints here and there of other wireless technologies, most from the perspective of how they interfere with Wi-Fi and so forth. CWSA says, hey, there's a much larger wireless world as well, so we're going to start learning about it. It's the foundation. It won't be overwhelming in its technical depth, but it's going to give you a solid understanding of the technologies and what roles an administrator might play in relation to those. And I mean technologies, of course, like 5G LTE, IoT, proprietary to some extent, though we're not going to get into the details of how they work at all, but just referencing some of them and how they work. We're going to see information on programmability, so APIs, things like that. Again, the starting point for that. And then later on in the track, you're going to begin learning about IoT in depth, 5G, private 5G in depth, systems integration through programming in depth. So that kind of thing is going to come as professional level certifications in that CWSA track. So certainly CWSA is a good place to begin. I'll be teaching the first ever CWSA class at our conference in September this year, as a matter of fact. And so if you want to kind of get first exposure to that, that'd be a good place to do it. Later professional level certifications then will focus on LTE, 5G private networks, but also other things in wireless networking outside of Wi-Fi. All right, with that, that's what we have scheduled to talk about today, kind of an opinion editorial piece on 5G. And I guess we could sum it up by saying 5G will not kill Wi-Fi. So let me thank you for joining today.